For this, you need your paper or your notebook, 2 colors, and your very expensive ruler. Okay? You'll never guess it, but I'm going to divide this into Mr. J notes. Title. Spot at the bottom for summary or exercises. And lastly, space on the side to organize our thoughts. Okay? So, today we're going to look at scientific notation. And as we said, it's for really big numbers or really small numbers. But today I only want to focus on really big numbers. The next video will look at really small numbers, okay? So, the first thing, why? I want to talk about why we even use scientific notation. Now, we did say that we could write 6,000 as 6 times 1,000, or even shorter, 6 times 10 to the 1, 2, 3. Okay? So one way to write 6,000 is 6 times 10 to the 3, and there's your scientific notation. Of course, we could have even bigger numbers, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now that's extremely obnoxious to write. We could write that as 7 times 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so there's 12 zeros, 12 zeros. Or to even make this smaller, 7 times 10 to the, there's 12 zeros, so number 12. So the really big numbers, it makes it pretty easy. And let's just say we have 8 times 10 to the 24. This is a lot easier. I'll write it in a different color. A lot easier than 8 with 24 zeros. Okay? So, the reason we do this, why, is for today's lesson to write really big numbers in an easier way. Okay? So really we do this so that we can write really big numbers in an easier way. Okay. So, let's do a little practice. Let's do 1, 2, 3, 4, 5, 6. First one we're going to do 5 times 10 to the 4. We know that is equals 5 and then 4 zeros. Oh, I put the decimal that wrong. So ignore. There you go. 50,000. So that 10 to the 4 is 10,000. 5 times 10,000. Now let's do 9 times 10 to the 6. So in this case we have 9 with 6 zeros. 1, 2, 3, 4, 5, 6. 9 million. And one more example here. Let's do 3 times 10 to the 7. Hopefully you're recognizing now this is going to be 3 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay. So what we just looked at right now is when we have a whole number, you just add the zeros. Now, let's see what happens when we change with a decimal. For example, 5.3 times 10 to the 4. If we think about this, 5.3 times 10,000, instead of 4 zeros, it's going to be 1 and then 3 zeros. So here's your first space, and then 3 zeros. So now instead of 50,000, it's 53,000 because it's 5.3. That may be a little confusing, so let's try another one. 9.2 times 10 to the 6. So in this case, we kind of added 1, 2, 3, 1, 2, 3, 6. So here we're going to do 1, 2, 3, 1, 2, 3. So this takes up one of our zeros and gives us, so we have 9 with theirs, we have our 1, 2, 3, 4, 5, 6. So instead of 9 million, it's 9,200,000 or 9.2 times 10 to the 6. Okay? So let's do one more practice like that. 3.9 times 10 to the 7. One more time. The 7 means we added 7 spaces after. So they're all zeros. Here, one of those spaces is going to be the 9, and then 6 zeros. 1, so 3, 4, 5, 6, 7. So this equals 3. Your first space is the 9, and then 6 zeros. 2, 3, 4, 5, 6, 7. So we have 6 zeros in the 9 because we have the decimal. And we'll do one more here. We'll call it 7 because we just did 6. What if you have like 4.369 times 10 to the 8? This we have kind of seen in real life. Again, this 8 just means 8 spaces. So 1, 2, 3, and then the next 5 are going to be zeros. So 1, 2, 3, 4, 5. So we have 4, 3, 6, 9. These are our first 3 spaces. And then 5 more to get to that 8. Okay? So this 8, what are we learning? This 8, the exponent, in scientific notation means to move that many spaces to the right. And if you have extra spaces after the decimal, you add zeros. Okay, so if you have a decimal, you add your zeros. And if you're watching this, write your name right here. Okay? So write your name right here if you're watching this. Name right here. Okay? Alright. The next part is going to be a little confusing. We're going to quickly and then do some practice with it. We'll just say more information. I'm going to write it in words and see what it says. The first number has a digit in the ones place. So what I mean by that, if we look at our examples from above, 3.9 times 10 to the 7, biggest place is in the ones. Okay? Now let's look at non-examples. So these are non, which means they're not examples, okay? One would be like 10.5 times 10 to the 8. So this is not an example because it has tens place. What about 0.8 times 10 to the 7? This is not because there's nothing in the ones. So it has to have something in the ones place. Okay? Now, this may be confusing when I explain it. Another way to say this is the first number is bigger or equal to 1, which means 1.1 or 1.001 or just 1 or 1.9 and then forever. But it is smaller than 10. So the maximum it could be, well, not the maximum, but this means it could be like 9.999999. It could be 9.9999999, as long as it's less than 10. What that means is, for each one, you only have a number in the ones place. Okay? So, I'm going to do 2 more examples here and then you do exercises. If you want to divide this in half. Let's say we have the number 68712. So we're going to ask ourselves, how many spaces until the ones? So for example, thinking backwards, we have 1, 2, 3, 4, 5, 6, 7 spaces. So we're going to have 6.87, those are our numbers, times 10. We said 1, 2, 3, 4, 5, 6, 7. If we think about this backwards, 7 spaces, 1, 2, and then 5 zeros. This is probably the most confusing part for students. Let's do another example. 9, 3, 8, 4, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, we have this really huge number, which is million, billion, trillion. So 93 trillion. So we want to count how many spaces until the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's times 10 to the 13. And the number is going to be 9 in the ones place point, and then the numbers after it, but without the zeros. Okay? Watch that part again if you don't understand. So your exercises are going to be short this time. You're welcome. Just 2. So for one example, let's do 9.65 times 10 to the 6 equals, and make that one normal number, and then we'll go backwards. So 5830000 equals, and then tell me that one in scientific notation. Okay? I think this topic is a little confusing at first. We will practice it more, but try your best with the video. If you don't understand, remember you can rewind parts, watch them again. Some fancy computers, you can change the speed, go to like 1.5, so I sound like this. Okay? So good luck.